Good afternoon. It occurred to me this morning that Northeast Pennsylvania is one of the few places, probably the only place, I guess, in the country where you can find all of UGI's domestic operations. As most of you are probably familiar with, our big operation is our natural gas company. We're the largest natural gas distribution company in Pennsylvania. We also operate a small electric division that's located in the Wilkes-Barre area. Just to give a little bit of an idea of who UGI is, I'm sure most of you are familiar with the name, probably not familiar with the breadth of business that we have. UGI Corporation is headquartered in Valley Forge. It's a little over 135 years old, and in addition to natural gas and electric distribution, we're involved with retail marketing, midstream, underground gas storage, some transmission, LNG. We have various solar, landfill gas projects and so forth, doing power production. And as well, UGI Corporation owns a number of European propane distribution companies, as well as a controlling interest in AmeriGas propane. What I'm going to talk about today is a little bit about combined heat and power. Just kind of digging into some of the details without getting too detailed. Give a little bit of an overview of what it is and why it's good and so forth. And then also talk a little bit about conversion. When I first heard about combined heat and power, about 5-7 years ago, something like that, people were talking about CHP, and then those of us who've been around the industry for a long time know CHP was just a rebranded name for cogeneration. Cogенeration's been around for a long time. CHP became like a new thing, and I thought, what the hell is CHP? And no, it's not chips. But this is what it is. The schematic here, and I apologize for those of you who are in the back that may have a difficult time seeing this, but this schematic that's up on the screen here shows more of a traditional thermal electric process for a plant, industrial plant, or a commercial application. On the top of the screen shows the thermal side of the equation. That's a traditional boiler being fed with water, natural gas, where you have steam or hot water coming off the end and being used, and then electric coming in off the poles. The problem with this, or where it is less ideal, has to do with the efficiencies. The thermal process is only about 75% efficient. You lose about 25% of the stack by way of waste heat. And on the electric side, due to conversion from fuel to electricity and transmission losses and so forth, that is only about 32% efficient. What combined heat and power does is essentially combine the two to get the best of both worlds. Where on the top, it leaves us with 80% plus efficient, and obviously this really depends on a lot of things, load profile, application, exactly how things are being done and so forth. But what you see down there in the kind of aqua-colored box is the CHP system. We have natural gas coming in, firing a turbine or a reciprocating engine or some form of process that's generating electricity, and rather than putting the waste heat up the stack, the waste heat is turned over to a heat recovery unit where that heat can be turned into something useful, put into a traditional boiler, extracting that heat and making hot water, steam from it. And the end process is that the customer is able to generate a portion of their electricity. If done correctly, it's probably not all of their electricity, but if it's done correctly, it will provide all of their thermal needs, so all of their heat, all of their industrial load, heat and hot water, and so forth. And also, potentially, air conditioning that is through something called tri-generation. Some of you may have heard of that. That's basically where the waste heat is put into an absorption chiller and actually can create air conditioning. So the words behind this, you saw the picture, but the words are, it's the sequential production of both electrical and useful thermal energy from a single energy source, which in our world we would all like that to be natural gas, although it doesn't have to be natural gas. And there are certainly applications around the state that aren't natural gas, like biofuels and landfill gas and things like that. There are examples of those, but the lion's share of them are natural gas. Traditional model, only a third of the energy that's burned by the electric plant is converted into energy. Electricity, the rest is rejected as waste heat up the stack through the steam and so forth that you see up in the air. And what CHP does, combined heat power does, is recycles effectively that waste heat where it can be used for other things. And that greater efficiency lowers not only the annual energy costs, but also reduces carbon emissions by an average of 20 to 40%. Just as a footnote, that is based off of what is more of a historic trend in Pennsylvania, where the majority of the electricity is generated with coal. Obviously, the more electricity that's generated with natural gas, the less savings there is on the carbon. Why is this a good thing? Obviously, the big thing is cost savings. Cost savings can produce up to a 2/3 reduction in total cost. Power reliability is a big factor. It is possible that a combined heat power system can certainly power the critical load, not necessarily peak load or full production load, but for the things that you would typically back up with an emergency generator, the CHP can keep that so that if the grid goes down, you don't have to worry about those critical systems being impacted. And that's very big for data centers, for some critical manufacturing where power reliability is extremely important. It also gives a more consistent power, so you're not subject to some of the grid voltage variations and so forth. Some of the societal benefits, and this kind of gets to some of the reasons why in some states like Massachusetts there's been a real movement to encourage the use of combined heat power through carbon credits that essentially, what they've done there is actually pretty innovative. I'd like to see it in Pennsylvania, but what they've done there is essentially give the heat produced by a CHP unit the equivalent of a carbon credit that can be then again sold, traded, and so forth. And so really looking at this as a real good way to reduce carbon footprint. But from a national security perspective, obviously grid goes down and chaos ensues, and so some of those critical systems, the support centers and so forth, that can have this make combined heat power or distributed generation for that matter, keeps those lights on in those places. Reduce costs for new infrastructure. We talked a little bit last week, for those of you who were at the Marcellus Shale Coalition's member meeting last week in our gas use committee. We talked a little bit about the shortfall in power that we're facing in Pennsylvania with some of the retirements of coal plants and so forth. And one of the things that's going to step up is demand side management. Combined heat power is a huge opportunity. It gives us a huge opportunity to reduce the need for new transmission infrastructure, new power plants, and so forth by essentially decentralizing that electricity generation. Obviously, local jobs, we all know that. And then environmental, as I mentioned earlier. Keys for combined heat power. Number one, don't size it for the electrical load, size it for the thermal load. Anybody who works with CHP or cogeneration, that's the first thing they'll tell you. Don't put in more power than, don't put in your power requirement, put it into size for thermal load. So you're essentially getting free electricity. That's really, really important. The other thing that's very important is load profile. You want to definitely have an application that has a strong year-round load profile. So something that uses natural gas strictly for heat, probably not a great application. Something that uses natural gas for laundry, food service, some of the industrial applications, those are perfect. And where we've seen a number of excellent applications are at those very same facilities. Penn State University and State College has a very large CHP system. Bucknell has and I think Secretary Walker left, he probably would jump up and down and cheer for this, but Bucknell has a really neat system up there. Not only are they doing cogeneration, they're putting it out into their central steam system, but they have two different pressure steam systems, so they actually have a turbine on their steam turn down, so they actually have like two turbines, one that fires natural gas, one that uses that uses the waste heat from that, and then another one that's used to regulate the steam pressure in their central system. Geisinger Health in Danville recently put in, I think it's 5 megawatts of cogen. Reading Hospital in Reading, Pennsylvania recently put in 10 megawatts. Williamsport Hospital, through some, with the help of some grant money, put in through the stimulus grants, put in I think it's a reciprocating engine combined power plant. Mountjoy Wires, an industrial application. Procter & Gamble, just north of here, has a very large combined heat power system that generates almost the entire plant's needs today with natural gas. Albright College in Reading, Four Seasons Hotel in Philadelphia. Four Seasons actually is a micro turbine application where they put these micro turbines on the roof of the hotel, and they use the waste heat for laundry and things like that. Masonic Home in Elizabethtown is a very large retirement home. That's also a capstone application in the PSCC building, which is probably under construction right now. I'm not exactly sure where that stands, but that's kind of a case study for power reliability that provides the backup. It's their big data center for the credit union. Here's some resources. Are these going to be, the slides going to be available later? Okay. So here's some resources if you want to find out more about combined heat power. And finally, I'll talk just quickly about some conversions that we've seen to give you a sense. And that's one of the things that I was talking with Scott a couple of weeks ago. And I said, well, you know what, the number one thing that we want people to know is that they need to convert to gas. I mean, you'd think that would be pretty straightforward, everybody would get it, but not everybody does. And a lot of that has to do with the fact that they don't know the gas is nearby necessarily. They aren't necessarily aware of how much they can save. But here's some case studies, and I'm going to start with the one that I like to see. And I'm going to give a little plug here for the Shale Gas Insight meeting in Philadelphia in September, where we're going to have a poster session to highlight some of these things in more detail, and maybe even have some of the representatives of these companies there to talk about how important these conversions were. I am very familiar with the GEO project. I should have mentioned earlier, I spent about 15 years with UGI's utility division, and I worked very closely with Geospecialty Chemicals outside of Allentown on this conversion. The plant was literally on the brink of closing because they were 6-oil user, and they just couldn't stay. They couldn't continue to pay for the oil. The utility worked with them and ran a new gas line there. The GEO is saving between $2.5 and $3 million per year. Payback on that project was less than 1 year. The doors are still open, the plant is still viable. They export chemicals worldwide. It's a great success story. But what's even cooler about this project is that got the gas that much closer that Parkland High School, if those of you who know Allentown, Parkland High School, Parkland School District is a very large school district. That high school is just built about 6-7 years ago, something like that. Big high school on oil. And as a result of us bringing this gas line to GEO, we were able to extend it and make it economical for that high school to convert to gas. And that's also a great story. They're projecting around $400,000 annual savings. And that goes right in the pockets of the taxpayer, or keeps the money in the pockets of the taxpayer. Altadis USA, not far from here, in Schuylkill County, south here, cigar manufacturer. A couple of years ago, UGI ran a 5-mile main extension. They're saving about $1 million in operating expenses. Some other examples, Lafarge Cement, Whitehall, Lehigh County, converted their cement plant. Tower Products, Northampton County, Berks County Prison, and Heim. That was primarily a heating conversion that was done. But these are all great examples, and I want to give a shout out to my friends over there from our utility. Raise your hand, guys. If your business is not using natural gas, talk to these guys. If gas is available, they'll make sure they'll